Hey everyone, and welcome back. Ready for another deep dive? Today we're tackling something that I know is important to a lot of our listeners, ovarian cancer. And specifically, um, the really crucial need for catching it early. Because like a lot of cancers, early detection makes a world of difference. But with ovarian cancer, it's particularly tricky, right? It's often diagnosed really late. And that obviously makes treatment so much tougher. So, I think there's a good chance many of you listening either know someone who's been affected by this or maybe even have some concerns yourself. So wouldn't it be amazing if we had a way to catch it early, when treatment is most effective? Well, guess what? There's some exciting research that suggests we might be getting closer. There's this brand new study. It was just published in the journal Cancers, and it's generating a ton of buzz because it hints at a potential breakthrough. Like we might be on the verge of having much better ways to detect ovarian cancer in its earliest stages. And to help us really understand the nitty-gritty of this research, we've got our expert here who knows this field inside and out. So let's just jump right in. The study starts off, by kind of laying out the facts. Ovarian cancer, as many of you probably know, is the 8th most common cancer in women. And the 5-year survival rate is really tied to how early it's caught. If it's detected at stage 1, the survival rate is something like 90%, which is credible, right? But if it's not found until stage 4, that number drops to just 20%. That's a huge difference, and it really, really drives home just how vital early detection is. The problem is, the biomarkers we currently have for ovarian cancer, well, they're just not that great. And that's precisely why this new research is so potentially groundbreaking. It's looking at a completely new approach, one that could totally change the game.
So what they did in this study is they used this really advanced technology called next-generation plasma proteomics. It's kind of like taking this incredibly detailed snapshot of all the proteins that are circulating in your blood.
Okay, I'm already a little lost.
Yeah.
Next generation plasma proteomics. Can we maybe unpack that a bit? What does that even mean?
Sure. So think of your blood like a bustling city, okay? And there are all these proteins rushing around, doing their thing. Proteomics allows us to identify and actually measure all of those proteins. It gives us this really, really in-depth view of what's happening at like the molecular level. And in this particular study, they used this cutting-edge technology to look at the blood of 2 groups of patients. One group had benign ovarian tumors, and the other group had malignant tumors, which means cancerous.
Gotcha. So they're essentially looking for differences, right? Like, are there specific proteins that kind of jump out as red flags for cancer?
Exactly. They measured a mind-blowing 1,463 proteins in each blood sample, and they were searching for any proteins that showed noticeable differences between those 2 groups.
Wow, 1,463 proteins. I mean, that's a ton of data. So did they find anything?
They did. It's pretty amazing. They found 32 proteins that were significantly higher in the women who had malignant tumors. And to make it even more convincing, 28 of those same proteins were then confirmed in a second group of patients.
So significant in this case means it's not just a coincidence, right? It's like a strong signal that these proteins are actually linked to cancer being present.
Exactly. But they didn't stop there. They actually went on to develop several models. You can think of them as prediction formulas. And they used combinations of these proteins to see if they could, accurately tell if a tumor was benign or cancerous just based on those protein levels in the blood.
Okay, that's incredible. So just a handful of proteins might be all it takes to tell us whether someone has cancer.
Yeah, it's pretty remarkable how accurate these models turned out to be. They achieved these really high AUC values, which is a measure of how well the test can distinguish between, in this case, benign and malignant tumors.
So you're saying these models are really good at predicting whether a tumor is cancerous or not?
Right. And it gets even more interesting because they also created models to try and differentiate between early and late stage cancer. That could be incredibly valuable down the line.
Oh, wow, this is getting really exciting. So tell me, which proteins were the stars of the show? The ones that, were really important in these prediction models?
All right, so the model zeroed in on 11 key proteins. There's ALPP, CXCL8, DPY30, IL6, IL12. Also PRT19, PAEP, TSPAN1, CKP5, VTCN1, and WFDC2. Now, I know those are a mouthful, but some of them might ring a bell for those of you who follow this field. But what's really fascinating is that, what these 11 proteins actually do in the body. Well, they're giving us some clues, like little hints about what might be going on, even in the very earliest stages of the disease.
Ooh, clues. I love it. So tell me, what kind of clues are we talking about here?
Well, let's take a look at IL-6, for example.
Yeah.
It's involved in inflammation, and, chronic inflammation can actually create an environment in the body that makes it easier for cancer to develop.
Right, so it makes sense that if we see higher levels of these inflammatory proteins, it can be like an early warning sign, right? Something's up.
Exactly. And it's not just inflammation. A lot of the other proteins on this list, like CXCL8, they're involved in the immune response.
So is it possible that the body is actually trying to fight off the cancer early on, but maybe it's not quite winning that battle? Like, are we seeing that play out at the molecular level with these proteins?
That's a really interesting thought. And, there's growing evidence that the immune system plays a very complex role when it comes to cancer. It can help control tumor growth, but sometimes it can actually end up promoting it, which is kind of counterintuitive.
Yeah.
So these elevated protein levels could be a sign of that back and forth, that tug of war between the immune system and the tumor as it's developing.
That's fascinating. So figuring out how those proteins work with the immune system could be key to new treatments, right? Like, could we help boost the body's defenses so it can actually fight the cancer more effectively?
Absolutely. Immunotherapy is already making huge strides in cancer treatment in general, and findings like this could open up a whole new world for developing more targeted, more effective immunotherapies, specifically for ovarian cancer.
So it's like giving the body's own army the right weapons to win that battle, right?
Exactly.
Okay, I'm loving this. So we've got inflammation, we've got the immune system. What else are these proteins telling us? What other clues do they give us about how ovarian cancer actually develops?
Well, there's another interesting one on the list called KRT19. It's a type of keratin which helps to form the structure of cells.
Interesting. So does that mean it's involved in, like, how cancer cells grow and spread?
Well, we know that elevated KRT19 has been linked to tumor growth and spread in a few different cancers, including ovarian cancer.
Wait, spread, you mean metastasis, when cancer cells break away and travel to other parts of the body?
Yes, exactly. And that's one of the most challenging aspects of ovarian cancer. It often spreads before it even causes any symptoms, which is why finding it early is so crucial.
So if these biomarkers can give us clues about whether a cancer is likely to spread, that's huge, right? Because then doctors could maybe be more aggressive with treatment early on to try and prevent it from spreading.
You got it. If we can identify patients who are at high risk of metastasis right from the start, we can tailor their treatment plan to be more aggressive, potentially using therapies that are specifically designed to, stop the cancer in its tracks.
This is amazing. So we're not just talking about catching cancer early, we're also talking about understanding how it might behave and making smarter choices about treatment.
That's the real power of this research. It's not just about finding a needle in a haystack. It's about understanding the haystack itself, like really getting a grasp on the complex biology of ovarian cancer, and then using that knowledge to develop better tools, both for diagnosis and treatment.
Okay, but with all these different proteins and pathways, it seems incredibly complicated. How do researchers even begin to make sense of it all?
Well, that's where bioinformatics comes in. And computational modeling. Researchers are using these incredibly sophisticated algorithms to analyze all the data from these new technologies. These algorithms can pick up on patterns and connections between different proteins, figure out which ones are most strongly linked to the disease, and even predict how those proteins might be interacting with each other.
It's like having a superpower detective on the case, right? Using high-tech tools to solve the mystery of ovarian cancer.
Exactly. And as these technologies keep getting better, we're only going to get better at solving this puzzle.
This is seriously exciting stuff. But, it makes me wonder, not everyone has access to these cutting-edge technologies, right?
Yeah.
What does that mean for the future of ovarian cancer diagnosis and treatment, especially for women who might not have the resources to get these tests?
That's a crucial point. While this research is incredibly promising, we have to make sure that everyone benefits from it. No matter their background, their socioeconomic status, where they live, access to these advances has to be equitable. We can't let these breakthroughs worsen existing health disparities.
Couldn't agree more. We need to make sure everyone has a chance to benefit from this kind of progress. Okay, before we move on to even more fascinating aspects of this research, I want to leave our listeners with something to think about. If these biomarkers really are reflecting the body's first attempts to fight off this cancer, what does that tell us about prevention? Could we actually intervene even earlier, before the disease even has a chance to take hold?
Now that is a question worth pondering. The possibility of shifting our focus from reaction to prevention is incredibly exciting. And this research really does give us some tantalizing clues about where to start.
Okay, I am on the edge of my seat. So where do we begin? Where do we even look for these preventive measures? It seems like we're talking about stopping cancer before it even starts. That sounds almost like science fiction.
Well, it might sound futuristic, but the seeds of possibility are definitely there. I think one really promising path is to delve deeper into what these biomarker proteins actually do. If we can pinpoint exactly which pathways they're involved in and how those pathways contribute to cancer development, we might be able to develop very targeted interventions, strategies that disrupt those processes and stop the cancer from forming in the first place.
So we're not just trying to detect the disease, we're trying to understand the very mechanisms that make it happen.
Yeah.
And then find ways to, like, throw a wrench in the gears.
Exactly. And that's where the whole field of precision medicine comes in. The idea of tailoring treatments and prevention strategies to each person's individual genetic and molecular makeup.
So instead of a one-size-fits-all approach, we're moving towards personalized medicine, where your treatment or prevention plan is as unique as you are.
Precisely. And these biomarkers could be a crucial part of making that happen. Imagine, in the future you could get a simple blood test. And it would not only tell you if you have ovarian cancer, but also reveal your individual risk factors and point to the most effective ways to prevent it from developing in the first place.
That is incredible. So what would those preventive measures actually look like? Are we talking medications, lifestyle changes, something else entirely?
It could be a mix of different approaches, actually. For some people, it might involve lifestyle modifications, like changes to their diet or increasing physical activity, which we know can reduce cancer risk in general. And for others, it might involve targeted therapies that specifically address the pathways that are out of whack based on their unique biomarker profile.
So like if inflammation seems to be a big driver for someone, based on those elevated levels of IL-6 or other markers, we could use anti-inflammatory medications or other interventions to try to reduce their risk.
Exactly. But this is where the collaboration between researchers, clinicians, and patients is so important. We need to do large-scale clinical trials to really test how well these personalized preventative strategies work and to make sure they're safe and actually beneficial.
And of course, we can't forget about making sure that everyone has the opportunity to benefit from these advances.
Absolutely. Access and equity are paramount. We have to break down any barriers that prevent people from getting the care they need.
I couldn't agree more. Okay, this has been an incredible deep dive so far. We've covered so much ground, from discovering these promising new biomarkers to exploring their potential for early detection, personalized treatment, and even prevention. It feels like we're on the verge of a major shift in how we approach this disease, and that is incredibly exciting.
It really is an amazing time to be working in this field. And, as we continue to learn more about the complexities of ovarian cancer, I have no doubt that we're going to see even more groundbreaking discoveries that will change countless lives.
It's a future filled with hope. So to all our listeners out there, stay curious, stay informed, and stay tuned for more deep dives into the world of cutting-edge science. Until next time.
So those 11 proteins, yeah, they're like these little messengers giving us hints about what's going on in the body, even in those very first stages of the disease.
Ooh, hints. Okay, I'm intrigued. What kind of hints are we talking about here?
Well, some of these proteins are involved in inflammation, like IL-6, and when you have chronic inflammation in the body, it can actually create this environment that makes it easier for cancer to take hold.
That makes sense. So if you see these inflammatory proteins at higher levels, it's like a little red flag, right?
Yeah.
Like, something might be a bit off here.
Exactly. And it's not just inflammation either. Several other proteins on this list, like CXCL8, for instance, they're involved in the immune response.
So is it possible then that the body's actually trying to fight off the cancer in those early stages? But maybe it's not quite strong enough yet? Like we're actually seeing that struggle play out at the molecular level with these proteins?
That's a really interesting way to think about it. And, there's more and more evidence that the immune system plays this really complex role with cancer. It can help keep those tumors in check, but sometimes it can actually end up promoting cancer growth, which is kind of wild when you think about it. So those higher protein levels, they could actually be a sign of that back and forth, that tug of war between the immune system and the tumor.
Wow, that's pretty mind-blowing. So figuring out exactly how these proteins interact with the immune system, that could be a game changer for developing new treatments, right? Like, could we potentially boost the body's own defenses, make them stronger so they can fight the cancer more effectively?
Absolutely. Immunotherapy is already revolutionizing the way we treat cancer. And findings like this, they open up all sorts of possibilities for developing more targeted and hopefully more effective immunotherapies, specifically for ovarian cancer.
I love that. Like we're giving the body's own army the right tools to win the battle.
Exactly.
This is fascinating stuff. So we've got inflammation, we've got the immune response. What else? What other clues are these proteins giving us about how ovarian cancer develops.
Well, there's another protein on this list that's really interesting, KRT19. It's a type of keratin, and keratins are these proteins that help form the structure of our cells.
Okay, so does that mean this one's involved in how cancer cells grow and spread?
It's certainly possible. We know that when KRT19 is elevated, it's been linked to tumor growth and spread in a number of different cancers, including ovarian cancer.
Wait, spread you mean like metastasis? When the cancer cells break away from the original tumor and travel to other parts of the body?
Yeah, exactly. And that, unfortunately, is one of the biggest challenges with ovarian cancer. It often spreads before it even causes any noticeable symptoms, which just highlights why early detection is so incredibly important.
So if these biomarkers can give us clues about how likely a cancer is to spread, that could be incredibly valuable information for doctors, right? They could potentially start more aggressive treatment right away to try and stop it from spreading.
Absolutely. Being able to identify those patients who are at high risk of metastasis early on, it means we can tailor treatment plans to be more proactive, maybe even use therapies that are specifically designed to stop the cancer in its tracks.
Wow, this is really starting to paint a much clearer picture of just how powerful these biomarkers could be. It's not just about catching the cancer early. It's about understanding how it might behave and using that knowledge to make the best possible treatment decisions.
Yeah, and that's what's so exciting about this research. It's not just about finding a needle in a haystack. It's about, understanding the haystack itself, understanding the intricate biology of ovarian cancer, and then using that knowledge to come up with better tools for diagnosing and treating it.
This is amazing. But with all these different proteins and pathways, it all seems so incredibly complex. How do researchers even begin to wrap their heads around it all?
Well, that's where things like bioinformatics and computational modeling come into play. Researchers are using these sophisticated algorithms, really powerful tools, to analyze the mountains of data that these new technologies are generating. And these algorithms, they can pick up on patterns, connections between different proteins, and they can pinpoint the ones that are most strongly associated with the disease. And they can even predict how those different proteins might be interacting with each other.
So it's like having a superpowered detective on the case.
Right.
Using high-tech tools to solve the mystery of ovarian cancer.
Exactly. And the exciting thing is, these technologies are only going to get more advanced, which means we'll keep getting better at unraveling this puzzle and figuring out the secrets of ovarian cancer.
This is all incredibly exciting. But it makes me think about something else. Not everyone has access to these cutting-edge technologies, right? Especially in certain parts of the world, or for people who don't have a lot of resources. So what does that mean for the future of ovarian cancer diagnosis and treatment? How do we make sure these advances reach everyone who needs them?
That is a crucial point, and you're absolutely right. While this research holds so much promise, we have to make sure that everyone benefits. No matter their background, their socioeconomic status, where they live, access to these advances has to be equitable. We can't allow these breakthroughs to worsen the health disparities that already exist.
I completely agree. We have to work towards a future where everyone has a chance to benefit from this kind of progress. Okay, so before we wrap up this part of our deep dive, I want to leave our listeners with a question to ponder. If these biomarkers are really reflecting the body's initial attempts to fight off the cancer, what does that tell us about the possibility of prevention? Could we potentially intervene even earlier, before the disease has a chance to really take hold? That is the million-dollar question, isn't it? Can we actually stop cancer before it even starts?
It would be incredible, right, to shift our whole focus from reaction to prevention. And this research, it's giving us some pretty good clues about where to look.
Okay, so where do we even begin? I mean, it seems like we're talking about intercepting cancer at its very earliest stages.
It might sound like something out of science fiction, but I really do think it's possible. One promising avenue is to really dig into the functions of these biomarker proteins. Get a deeper understanding of what they do. If we can pinpoint exactly which pathways they're involved in and how those pathways contribute to cancer development, well, then we might be able to develop very targeted interventions, strategies that interrupt those processes.
So it's not just about detecting the disease. We're talking about getting a handle on the very mechanisms that drive it.
Exactly. And that's where this whole idea of precision medicine comes in, tailoring treatments and prevention strategies to an individual's unique genetic and molecular profile.
So instead of a one-size-fits-all approach, we're moving towards truly personalized medicine.
Precisely. And these biomarkers, they could be a critical part of making that happen. Imagine a future where a simple blood test could not only tell you if you have ovarian cancer, but also reveal your specific risk factors and point to the most effective ways to prevent it from developing in the first place.
That would be revolutionary. So what might those preventative measures actually look like? Are we talking about medications, lifestyle changes?
It's likely going to be a combination of things. For some people, it might involve lifestyle modifications, like changes to their diet or increasing physical activity. We know those can help reduce cancer risk in general. And for others, it might involve targeted therapies, something very specific that addresses the pathways we're seeing disrupted based on their biomarker profile.
So for instance, if inflammation seems to be a major driver for a particular patient, based on those elevated levels of IL-6 or other inflammatory markers, we could potentially use anti-inflammatory medications or other interventions to try and reduce their risk.
Exactly. But that's where collaboration is so important, researchers, clinicians, and patients all working together. We need large-scale clinical trials to rigorously evaluate these personalized preventive strategies and make sure they're safe and effective.
And of course, we need to ensure that everyone has access to these advances in personalized medicine.
100%. Access and equity are absolutely crucial. We have to work to break down the barriers that prevent people from getting the care they need.
Well said. This has been an incredible deep dive into the world of ovarian cancer research. We've covered so much, from those remarkable new biomarkers to the potential they hold for early detection, personalized treatment, and even prevention.
And the most exciting thing is, this is just the beginning. As we continue to unravel the complexities of this disease, I'm certain we'll see even more groundbreaking discoveries that will have a profound impact on the lives of countless women.
It's a future filled with hope. So to all our listeners out there, stay curious, stay informed, and stay tuned for more deep dives into the world of cutting-edge science. Until next time.